It goes without saying how important agriculture is to a society's growth. They form a sort of symbiotic relationship where one is always helping the other. Farms produce food so that civilizations can grow, develop, and learn new methods to better produce the food, and the cycle starts again. It's a cycle that's been running for over 10,000 years, from origination to standardization, revolution to industrialization. It's a landscape that's seen many developments to the food production, for better and for worse. In the modern era, the overlookings of the past to use artificial fertilizers for supplying the increase in demand led to drastic effects on the environment, leading to a more complicated relationship of keeping up with said demand, but not at the planet's expense. One way we are righting our wrongs is through the implementation of organic fertilizers such as compost and bone meal, along with new farming techniques such as crop rotation and companion planting, a system of organic agriculture. However, this is but a small step towards humanitarianism, hindered by other major factors. Every year, the effects of climate change due to the emissions of greenhouse gases become a bigger and more noticeable issue to the inhabitants of our planet. So it's up to us as a species to find ways to reduce our footprint in every life aspect possible, including agriculture. While organic crop production already reduces the emissions of greenhouse gases by not using synthetic fertilizers, tillage practices still contribute to CO2 emissions through the fuel consumption of machinery like this tractor, incorporation of crop residue, and oxidizing soil carbon. A possible solution to these effects would be to either reduce or totally eliminate the use of tillage, but that leaves us with another problem, as tillage is hugely responsible for soil fertility and weed management. So the question we're left with is, how can we reduce the levels of tillage reliance, thus greenhouse gas emissions in our farming systems, while still being able to control soil fertility and manage weeds? Well, there are alternatives currently being tested, such as green manure mulches on systems with no tillage that show promising results in the short term, as well as livestock grazing reducing the necessity of tillage. Just how effective are these alternatives? Well, researchers at the University of Alberta asked themselves that question and are dedicated to finding the answer. So here's how they went about designing their experiment. They took a plot of land at the Lacombe Research and Development Center, divided it into 4 different sections, and then went into 9 phases for each of the rotation systems. The first 4 will be treated to a conventional tillage system. Cultivation followed by weeding before seeding in the spring, then disking after harvest in the fall. 3 plots will be treated with a reduced tillage system, with 3 different crops being wheat, pea, and oat. Harrowing will be applied to the wheat and pea crops, but for the oats, red clover will be broadcasted and allowed to grow as a cover crop, suppressing weed populations. Underseeded red clover will be left on the plot after harvesting, regrow the following year as green manure, be terminated, and left on the ground as mulch for the next growing season. The final 2 plots will be treated with an integrated crop livestock system designed to identify the benefits and drawbacks associated with integrated livestock. Calves or heifers will be introduced to the plots, grazing on the green manures, otherwise it's identical to the conventional system. Now, to help illustrate the process of collecting data for the purpose of this video, I've enlisted the 2 parties to work together that made this happen. The farmer, howdy, and the scientist. Hello. Guys, does this all make sense? Actually, I'm trying to figure out something. Why we got Bill Nye back here if I'm the one that runs the farm? Excuse me? You couldn't formulate a plan to run a bath, let alone a farm. How about you formulate a plan to mind your own business? Guys, please, this is supposed to be a collaboration. You're supposed to work together, all right? Now, farmer, let's go down to Lacombe to collect samples for the scientists to analyze, okay? Yeah, all right. All right, we'll see you guys there. All right, so here's where all your samples are, huh? Yep, this is pretty much all of it. Now tell me, what kind of scientifical, magical rigmarole is that scientist going to be doing with my farmland in his lab? Well, it's a bit more complicated than that, really. He's reading a lot about the nitrous oxide emissions, the greenhouse gas emissions, the particulate organic matter, you know, that kind of thing. Yeah, you lost me at like nitrous oxide, man. All right, well, I'm gonna ask your supervisor some questions about the farmland, and I'll come back and collect the samples, all right? Yeah, so that sounds good. All right, cool. See you in a little bit then. Well, hey, put in a good word for me. Wait a minute. Supervisor? I thought this was my farm. So first, why don't you tell us a little bit about yourself?
Okay, my name is Hiroshi Kubota, and I'm a research scientist in Lacombe Research Station, Agriculture, Canada.
So what brought you here before this, and how did you get your start into agriculture?
Okay, so basically, it's gonna be a long story, but to make it short, originally I'm from Japan, and I know that many of the food that we eat in Japan came from Canada, like canola, wheat, and barley, and so on. So I was really curious about knowing Canadian agriculture, and I came over here, and I did my master and PhD in plant science, University of Alberta, and my supervisor, he he has been doing organic research, so that's where I started interested in doing the organic agriculture research, and that's a kind of the beginning of the plot.
So what do you hope organic farmers will implement to their farms after this trial?
The concept of this study's outcome could be transferable and applicable to each organic farmers, which means that we are using cover cropping, and also we are testing integrated crop livestock systems, which may not be feasible for many organic farmers, but if it's possible, that could be a kind of a good solution to reduce the tillage. So the concept itself is transferable to every organic farmers.
So what do you think is a common misconception about organic agriculture?
Okay, I think one of the biggest misconception of organic agriculture is that organic agriculture itself is sustainable compared to conventional system. But actually, conventional system and organic system, they are both sustainable. And one of the criticism in organic agriculture in terms of the sustainability is that organic farmers, they don't have much tool to manage weeds, so they use more tillage. More often, they use a tillage than conventional farmers, and especially Western Canada. And that tillage is a kind of the big criticism, because tillage may disrupt and destroy their cropping soil systems and the microbial communities. And one of the big purpose of this study is looking at the opportunity to reduce the tillage in organic cropping system to manage weeds.
So why do you think this trial is important for Canadian agriculture?
Okay, so this trial, we try to implement cover cropping and integrated crop livestock system, so which may not be possible for many farmers, but still, as a researcher, we want to test the possibility of these cropping systems to help producers direct in the way that they can produce their crop as much as possible in a sustainable way. Yeah.
Awesome. All right, here are all the samples that we collected. All right, let's see if that peasant messed anything up. Now they should be fine. I'll see you when you get the results, right? Yeah, all right. All right, now we wait for the results to come in. So we're just gonna wait here until Einstein gets done with all his magic. Shouldn't take that long. I printed the wrong file. Got the results. All right, thank you. Why'd you fill out the entire board? Why'd I fill out the board? Because we have to record the data from all the plots during all the weeks for each of the plots for 4 years. 4 years? The Russians will have discovered a new element by then. Yeah, no way I'm working with the Geek Squad that long either. Yeah, it takes a long time to get done, but it's worth it, trust me. You know, why does any of this even matter? Why does it matter? Why does it matter? Looks like you're just writing a bunch of numbers on the board to me. Yeah, why should we even help him anyways? This matters because the information generated from this project will assist organic producers in deciding the cropping systems and practices that ensure environmental and economic sustainability, while also providing new science-based knowledge on net greenhouse gas emissions, carbon sequestration, and whole farm economics under different organic transitional systems, ultimately contributing to achieving the 2030 emissions reduction plan and the 2050 net zero emissions target in Canada, while maintaining the profitability of individual farms and the whole Canadian organic industry. That's why this matters, that's why this is so important, and that's why you guys need to work together and listen to each other, both farmers and scientists, to reach the goals that we've set so that we can live better lives. If that doesn't matter to you, I don't know what does. You know what, scientist man? I apologize for all the things I said about you. I just didn't understand your craft that well. And I apologize too. I was ignorant towards your field of expertise as well. Alright, put her there. I'm left-handed. Come on, let's get you more samples for you to analyze. Alright. And with that, we've reached the end of the video. Thank you so much for watching. As mentioned, this is a long project that will last till around the year 2027, which takes a huge amount of collaborative effort between a bunch of parties. So first, I want to thank the Soil Sciences and Sustainable Agro-Ecosystems Lab at the University of Alberta for having me as their intern. It was such an honor and a privilege to be here, to be able to record a video like this for them. I want to thank the people down at the Lacombe Research and Development Center for their amazing work on the farms themselves and all the research we can get out of them. Those guys do an amazing job also. I was gifted this opportunity to be an intern at the University of Alberta through a program called iSTEAM, which is a project that allows Indigenous students with an interest in biological sciences, such as myself, to get involved and experience the field firsthand. If this is something that interests you, please go to isteam-pathways.ualberta.ca for more info to get involved. Huge thanks to them. I love this program. I couldn't recommend it more to people. Finally, thank you to all the people that work in collaboration with the people in the lab and the farms for all the work that they can do, for all the help that we can get. I think there's a real beauty in the collaboration that comes out of projects like this. So anyway, thank you so much for watching. I hope you enjoyed. See you next time. Bye.